This tutorial looks at finding the length of a line segment. So in this case we have line segment AB, and we're going to find the length of that segment. Obviously in this case it's really easy just to count the number of squares, 1, 2, 3, and 4, to determine that the length of the segment is 4 units. That's not always going to be the case for something that has a much larger scale, or sometimes that's going to be very time consuming. So we're going to look at a different way to do that. So if you look at these 2 points, point A has a y coordinate of -3, as does point B, so the y values aren't changing. The only thing changing here from point A to point B are the x values, and as we counted there were sort of 4 steps in x values to get there. Another way to do that is to simply just take the x value of the B point and subtract the x value of the A point. 6 minus 2 is 4. So just in summary here, the length of AB is equal to x2 minus x1, in this case 6 minus 2, which is equal to 4. Now you might argue, why do you have to do it in that order? Couldn't you do 2 minus 6 and get an answer of -4? And the answer there is yes, that's true. We are looking for a length, so the positive negative don't matter. We're looking for the absolute value. We're looking for the size of the change. So if you did 2 minus 6 and got -4, you could just take the absolute value of that -4 and use that as a length. So that's the length of a horizontal line segment, fairly straightforward. Next we're going to look at the length of a vertical line segment. So if we just add in line segment BC, C having coordinates 6, 2, you'll notice again here that if we're finding the length of this vertical line segment, the x coordinates are the same. Both of the points have an x coordinate of 6. We're not shifting left or right, we're only moving up or down. And again, we could do the same thing, count the number of squares, or if we wanted to introduce a formula, we could find the length of BC by subtracting the y coordinates. So in this case, we could do 2 minus -3, which would give 5, so the length there would be 5. So far we've looked at finding the length of a horizontal segment and the length of a vertical segment. Those two are probably the easiest two to find. If we look at a line that's neither horizontal nor vertical, say such as line segment AC, things become a little trickier because we can't just look at those changes in one direction. So what we need to do really is to look at changes in both directions. Or, put another way, we now have a right triangle that we've constructed. So if we're given segment AC, we can construct a right triangle similar to a slope triangle that you might construct, and use the side lengths by finding the length of the horizontal line, the length of the vertical line, and then using the Pythagorean theorem. So using the Pythagorean theorem, we know that AC is going to equal AB squared, AC squared is going to equal AB squared plus BC squared. So the length of the hypotenuse squared equals the sum of the squares of the other two sides. Now up here you'll notice that we said that the length of AB was x2 minus x1. So if we replace in the Pythagorean theorem, we replace this AB squared with x2 minus x1 squared. So I'm just going to sort of drag this up in there. So AB is going to be replaced with x2 minus x1. And we're going to do the same thing for BC. We know that BC really came from up here where we have y2 minus y1. So we're going to replace AB with x2 minus x1 and BC with y2 minus y1. So if we do that, our equation for the hypotenuse squared becomes x2 minus x1 squared plus y2 minus y1 squared. Now obviously if we're going to find the length of the hypotenuse, we need to take the square root of both sides. So we need to be able to take the square root. So AC then would be the square root of the difference in the x values squared plus the difference in the y values squared. And this is a formula that works for the length of any line segment. If you have the coordinates of 2 points and you want to find the length or the distance between those 2 points, this formula will work because we generalize the formula by eliminating specific values and introducing sort of more generic terms that will always work. And we'll just work this out here in a moment. So to finish off, if we substitute the x coordinates for both points A and C and the y coordinates for A and C into the formula that we've just generated, we get something that looks more or less like this. From here it's just a matter of evaluating. Don't forget to evaluate the brackets first, then square the brackets, add the two values under the root sign, and then take the square root. So when we work inside the brackets first, simplify the brackets, 6 minus 2 is 4. 2 minus negative 3 does give us 5. We're going to square both of those values to get the square root of 16 plus 25. And then finally, if we finish it off, 16 and 25 works out to 41. So AC then is the square root of 41. And if we work that out on a calculator, you get approximately 6.4. So if you wanted to know what the value was, it would be approximately 6.4. And that's how to find the length of a line segment.